earliest matter was too far unstable to form the universe as we know it today. Think of it like this. 1,000,000 fish in the ocean. All of them look so random. That's what the subatomic particles look like in the first moments of the Big Bang. The extreme amount of energy that was happening at the time shocked all the subatomic particles with an extreme amount of energy. They disappear and then they'd appear. They'd race around at amazingly fast speeds. It's pure chaos. As the universe takes its shape, subatomic particles calm down in a sense. They become less random. As they cool down, the particles stop changing back into energy. Now you've got more subatomic particles and also more extreme amounts of energy with it. All of this is taking place in a smaller amount of time than we can even detect. Every coin, every shoe, every family photo, every rock, every plant, every house, every tree, every planet, every moon, every galaxy. None of these things existed 14 billion years ago. All they were was just a raging ball of compacted energy until the Big Bang happened. More subatomic particles and also more extreme amounts of energy with it. All of this is taking place in a smaller amount of time than we can even detect. Now the battle begins between matter and the one thing that can destroy the universe before it's even created: antimatter. This is home to one of the world's largest machines. It's the size of a city, and it's engineered to reenact conditions that happened at the time of the Big Bang. The machine's called a collider. It's a 12-foot wide circular concrete tunnel 17 miles around. The machine makes tiny particles of matter smash into each other at speeds almost the speed of light. The machine needs a monster detector, even more weight than the Eiffel Tower. Even the hugest of the machine can't totally see the collision, but it can see the travel of the particles. Pure energy caused the most dangerous thing in the universe to take shape. This kind of matter is the king of destruction, and it's called antimatter. This machine may also have the ability to create the one most dangerous thing in the whole universe: antimatter. Antimatter is a mirror image of regular matter, but matter has one charge and antimatter has the opposite. When these two types of matter shake hands, everything goes misfits from there. The fate of the universe is dependent on this epic battle. The side with the most soldiers wins. The battle's close, but one of them wins. The one extra matter that survives is enough matter to form what's in our universe today. Everything around you is the leftovers of the battle between matter and antimatter. Think about this event happening trillions and billions of times in every single volume. Luckily enough, it's enough matter to create the universe as we know it today. All the stars, planets, people, everything around you. The universe remains less than a second old. Tiny primitive particles now swarm through the universe. Now the next step, changing those primitive particles into the first atoms there are. Matter has won the battle between matter and antimatter, and now it's time to build the universe. It's still extremely hot and expanding rapidly fast, but now that's about to change. Temperatures continue to cool, and as the primitive particles are slowing down, they begin bonding together to create atoms of the first elements. The first element to form is hydrogen. Then over the next 3 minutes, the universe begins to create 2 more elements, helium and lithium. The universe went from smaller than an atom to thousands, millions of light years across in just a fraction of a second. In the first 3 minutes of the universe, everything that's interesting to us happened. When we look into the night sky, we're able to see millions of years into the past. But has it always been that way? "30,000 years after the Big Bang, everything was transparent. But was it always like that? The answer is no. Before it was transparent, it was very, extremely milky. "380,000 years is when it becomes transparent. There's a milky soup of loose electrons. The universe has to cool down for these electrons to slow down and stick to new atoms. It took a long time for hydrogen, helium, and lithium to form. Scientists calculate that it took about 380,000 years for them to cool down enough so that the universe can start mass-producing atoms. And that's when the first light escapes and races across the universe." Nearly 14 billion years later, scientists in New Jersey pick up it by accident. In 1964, Arno Penzias and Robert Wilson are mapping radio signals across our galaxy. Everywhere they looked, there was a strange They thought it was equipment, but it was not. It did not change. The hum continued rapidly. Interestingly, they were picking up the moments of creation. They were experiencing 380,000 years after the Big Bang, when the universe became transparent, and the first atoms were beginning to mass produce. The moment when the Milky Cloud clears. NASA then launched COBE. They pointed it out into space when it took the temperature of the moment of creation. You were looking at the first map of our early universe. Just not good enough. We needed something more than just this. Just the quality of the photo that was taken. It gave us a description of what our early universe looked like, but it was not good enough. When NASA launched the Wilkinson probe, they got a more beautiful advanced photo of our early universe. You were looking at the most sophisticated baby picture of our early universe. The universe is now 380,000 years old. It will take another 200 million years before the gases that flow through the universe make the first stars. 200 million years later, the lights turned on. 1 billion years after the Big Bang, the first galaxy formed. And just 5 billion years ago, in the corner of one of those countless galaxies, gravity started to pull in countless amounts of debris and gas. And that was the creation of our star. Then shortly after, our solar system was created. And then shortly after that, so was our Earth. The Big Bang as we know it is still going on as you watch this video, and it's not even close to being done. The Big Bang is the creation of everything as we know it in this universe. The universe is still rapidly expanding, rapidly growing. The Big Bang is yet to be over, and it will continue to happen for almost eternity. Parts of the universe are construction sites of the Big Bang. Other parts are developed, like the part we live in now. The universe had a beginning, but it will also have an end. We now think there's something called dark energy. This energy is the energy of nothing. We cannot see this force, but once this dark energy takes over, our galaxy could be a lonely outpost. We would have no galactic neighbors. Stars would burn out, and atoms themselves would tear apart. But don't worry, this will not happen for a long time. The creation of our universe was over in a flash, but the death of it will take almost eternity. This is the universe, full of stars, galaxies, and maybe planets like our own. Ladies and gentlemen, this is Clockwork Universe.